Hey everyone, we're back with another cool enterprise-y type video, except this is also interesting for the enthusiast space because we at GN, we've talked a lot about EPYC over the past couple of years as AMD has rolled it out. It is a lot of the reason that Ryzen exists in the capacity it does in desktop. So I have Wendell from Level 1 Techs here. You, at this point, may have seen him in some of our other videos. We've got a server build going up. That's why you came out as a server expert. And now we're going to talk about the expensive way to do a server, not the GN way to do a server. Before that, this video is brought to you by Linode Cloud Computing. We've trusted Linode as our web host since 2012 and recommend it for excellent technical and customer support, reliable uptime, and a clean interface. Aside from cloud hosting, Linode.com recently added GPU hosting plans for machine learning and neural net use, built with RTX 6000 GPUs and 10 gigabit per second network speeds. They're also starting to deploy EPYC CPUs in their servers. Sign up for Linode.com Cloud Computing with code GNEXUS20 for a $20 credit, or click the link in the description below to visit linode.com/gamersnexus.
This is exciting. But, well, I mean, because you guys do teardowns, you guys do like,
yes,
you know, the best of the best and this kind of stuff. And this is the fastest computer that mere mortals can lay their hands on. It's the world record holder. It's a 64 cores per CPU, 2 CPUs, 128 cores, 256 threads, up to 4 terabytes of memory. This holds currently, I think, 11 world records.
And so you've got it in a gigabyte chassis. We'll go through the cooling system too. And right now it's powered on. It's actually really quiet right now, but when you first power it up, it's deafening. It's got
standby power. So the baseband management controller's on, and we can remote into it over the web. And that's what we set up with your server. The IPMI,
right,
the ASpeed 2500, it's the same implementation.
Okay.
So this is the Gigabyte R282Z93. And so when you first turn it on, it sort of gets angry. I mean, that's fine. Okay, that's reasonable.
That's not bad. Andrew, is this picking up on the mic? I want to make sure they can hear this, and I'm not sure that they can.
Oh, they can hear it. They can definitely hear it.
Should we do a stream with this in the background?
What?
So it'll calm down eventually.
Yeah.
But it has some cool load balancing with the fans if you remove one or if one dies. I should probably stop talking until it stops. It's pretty blowy. So we're taking an anemometer right next to it. Wow, it is already at 1,500 linear feet per minute flow.
So it knows when you pull a fan. It knows, and it will compensate for that. It's like, hey, did that fan just die?
Holy shit. Jesus Christ. Look at that. 3,500 linear, 4,000 linear feet per minute. Holy fuck. Literally everybody in the building can hear that. Oh my God. So 4,000 linear feet per minute, if that means nothing to you for viewers. As an example, a lot of the, let's see, the 200 millimeter fans, opposite end of the spectrum, 200 millimeter fans, they'll be in like the 400 range, linear feet per minute flow. So
10 times that.
Yes, and it is linear, so it's linear feet per minute after all. So yeah, that is insane.
Yeah, I really like these chassis from Gigabyte. So I picked up some of their first gen EPYC chassis. So those with EPYC Naples, and I work on a lot of Dell and HP systems.
We should quiet this down for audio.
Let's see.
Okay.
There we go.
So you were saying you worked on a lot of Dell and HP systems.
Oh yeah, so this is a Gigabyte chassis with a Gigabyte motherboard. They've designed it. It's a PCI Express 4 risers. A lot of the modern EPYC Rome design servers is a mix of PCI Express 3, Gen 3 and Gen 4, depending on what the device is. It's a popular misconception that they were able to just drop Epic Rome into the old Naples servers. That basically didn't happen. Like, not Dell or HP or anybody. The boards required a little bit of rework. It is true that a lot of the world record holder systems were on pure PCI Express 3. They used all the PCI Express power budget to just give a little bit more push to the CPU to push it over the edge. But this chassis is designed for kind of a mixed workload. I don't think you would normally use 128 cores in this kind of a chassis because the storage density is not super high, and it's also got some room for GPU compute. So you could deploy up to 3 GPUs in here, like Tesla V100s or 2080 Ti's. Although the PCI Express devices are, like not every video card under the sun is qualified for use in a GPU chassis like this.
So when you got the fans to go super crazy, did you remove 2 or 1?
Just 1.
Just 1, okay. Do you know what the RPM is of these? We could find out with, I have a RPM, I have a tachometer, but.
I want to say it's like 3,000 or 3,500, but it could be more. I mean, these are,
They're small.
Yeah, Delta.
Oh, let's show the.
12 volts, 7 amps.
7 amps. So a lot of your consumer fans will be between like 0.1 and maybe 0.85 at like the really high end.
Yeah.
So, and a lot of headers on motherboards kind of max out at 1 amp. There's high amp headers too, like Asus has. But yeah, so 7 amps is...
High amp in that case is 3.
Yes, maybe. And it might just be 2. It's not 7. 7's quite high. Yeah, that's insane. So let's explain a few. I saw a brilliant analogy someone made on the least expected place on Reddit, actually. And someone was talking about, I think there was a critical comment from a DIY enthusiast about why are servers like this? Why do they have just a heatsink? This is worse than my home system. And the analogy I saw on Reddit, and I apologize, I don't remember your name, it was probably something very inappropriate being Reddit. It was, you have to think of it like if you're driving along the highway and you just stick your head out the window and open your mouth, like in terms of throughput from the speed of the vehicle, that's really all you need.
Yeah.
And so for the video card or for the CPU coolers,
they don't need cooling.
They don't, because its
head
is out the window. Yeah, right. Its head is out the window going 60 miles an hour. You're forcing all of the air in possible that can fit.
Yeah.
So it's a straightforward solution. Also, these go in racks where you can potentially have tons of them.
Yeah, 42U rack, a high density, ultimate compute per power. But that's also one of the world records that AMD holds, which is the efficiency of the compute per watt. So if you have a system like this in terms of density, in terms of like the Amazon AWS, if you were just using non-reserved instances, like just the default pricing that you get, if you were to like slice the server up as configured for Amazon Web Services, it would generate about $5,000 to $6,000 a month in Amazon equivalent web services for the number of VMs that it can run.
A lot, yeah.
And the processor is only $7,000, so I mean we're talking about an ROI of like 3.5 months, 4 months.
Yeah.
So
very good. And then the board is pretty unique too. Let's roll in and get a closer shot of this. So for the board, is this in any sense of it, is this a standard form factor or is this custom for?
It's standard in the sense that pretty much all servers follow the general formula that we have here in terms of power supply layout and this kind of thing. There's also these standards, like this is OCP3. This is the 3rd generation Open Compute Project interface. So your 100 gig Ethernet cards that are low profile, that are not going to consume an expansion slot, they'll slide in here. Underneath this, I don't think this is, I don't have this unscrewed, so this is not. This is going to take me a second.
Do we want to remove power? Or?
No, it's all right.
Okay. We should talk about the power supplies too in a bit.
So here's OCP Gen 2.
Okay.
And these are all modular. And the thing that I like about these chassis is that because they are super modular, this is configured for 3.5-inch drives in the front. This could be, you could dump all of your PCI Express lanes into NVMe in the front. You could have 24 NVMe slots. Not a problem. You could do crazy amounts of compute, whatever works. But generally, this kind of layout is pretty typical for a server. Another alternative layout is you've got those low-profile cards. Like you might notice Get the Intel solid state. This is strictly speaking a consumer drive, but have you noticed that certain PCI Express cards are only this high?
Yeah, yeah.
And so that's designed to be stacked in here vertically. So an alternative motherboard layout would be a ton of expansion slots, but they're all vertical half-height slots, as opposed to what we've done here, which is enough for 3, Tesla V100 sized graphics cards.
Yes. Yeah, and those I should note too, just like these Tesla V100s, stock do not have a fan on them. They just breathe the air in through the front of the case. And for the motherboard, so VRMs, let's talk about that. I think this should be pretty obvious to everyone on our channel, but there's no heatsink on the VRMs, no heatsink on the MOSFETs. As you'll know from our Buildzoid videos, if you've seen them rant about different VRMs of different qualities, if it's either a very good VRM or there's a ton of airflow, you don't necessarily need a heatsink.
Yeah.
And that's certainly true here with, first of all, these are right up against the fans, and there's a lot of airflow. And you've got some other VRMs back here. But heatsink's not necessary for that in this instance.
Yeah, they've taken the strategy of just distributing the VRMs uniformly throughout the motherboard.
Yeah, and then just dump air on it.
Yeah.
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 Air solves a lot of problems.
And it turns out it's a very effective strategy because the benchmark numbers from this system are so high, it's difficult to benchmark in any truly meaningful way because you end up having to run just 4 or 8 virtual machines that are all pegged, and then the software has trouble keeping up with.
Well, you have to start creating scenarios for benchmarks.
Yeah.
Yeah. And let's talk about the front end here. So drives, we can show maybe a shot of the front later or plug it in here. But so you've got removable drive bays, similar in concept to the disk shelf we had, but you've got that cool pop-out action. I'm going to set this back here.
This is really nice for hot swap. So this is the 3.5-inch configuration. I think if I were building a server for storage or for compute density, I would probably opt for spending the money on a bunch of NVMe devices. But if you were going to build a storage server or like a mixed duty workstation, you've got a ton of 3.5-inch drives here. And so these are relatively small 8 terabyte hard drives, 14 terabytes. That's what you have in yours. I think 20 terabytes are on the horizon.
Yeah.
So you could get a ton of local storage in this. It's mechanical storage, but you've got so much PCI Express connectivity that you can mix your PCI Express connectivity with NVMe plus storage, and all of the compute is local here. So it's a good mix of, it's a good everything server.
And what's the board behind it? What's the name for this?
This is, well...
Like, is it a patch board or is it?
It's really, this board is just designed for SAS and SATA. The interfaces here are SATA. So normally you have a backplane. And so generically this would be called a backplane. You can have smart backplanes and dumb backplanes. Okay. This is a dumb backplane, but like the disk shelf that you have is a smart backplane. And if you...
So what's your delineation there between the two?
The backplane will handle routing and failure much more intelligently if it is a smart backplane. Okay. So this backplane really just provides one-to-one connectivity with the motherboard, and it's up to the motherboard to recover from fault situations. Whereas a smart backplane will aggregate all of the traffic from all of the disks into as few links as possible, and then deliver that to the motherboard in aggregate.
And are these, where's stuff going here? So is that a SAS?
SATA.
SATA, okay. SATA going to, what's on the other end? Where does it terminate?
Similar connector, just on the backplane connector.
I see. Okay, gotcha. These are our fans?
Yep.
And then the cool thing about the fans too is it just pull up?
Yep.
Okay. So the cool thing on the fans is it's just sockets. So it's all pre-routed, you drop it in. And I guess you think about it in the sense of not as a consumer, but as a business, as an enterprise business. If you have a component go down, you really just want to be able to quickly remove the bad component and replace it.
Yep.
And
fans and power supplies are the most common failures.
Yeah, it makes sense, especially a fan. So for how much of this stuff is hot swap? I mean, these you can drop in and out, hot swap while it's running.
It's really just the fans and the power supplies.
Okay.
So
not the drives.
Well, the drives depend on the controller.
Okay.
So in this setup, the drives would actually be hot swap, but that's not necessarily true depending on what you're rolling with.
Okay.
And because these are direct CPU interface, that was a little sketchy in EPYC Naples, but it's much better in EPYC Rome. Ideally, some of that is handled by the backplane, especially a smart backplane will do a better job with that than a dumb backplane. But in this particular setup, basically they say it's okay at this point.
I'm not familiar with the enterprise world at all, but so for this type of application, how much do the cases really vary? I mean, if you're looking at chassis from Gigabyte versus someone else, are there meaningful differences in their design, or are they pretty much standardized?
I mean, the layout is standardized, but like the original design will be unique to each OEM. Like Dell and HP will spend a lot of time customizing and optimizing their design. One of the big differences is in like the software bundle. So like the IPMI that's on your system is very similar to this one. On a Dell or an HP system, that typically costs $300 retail. So like if you're just buying a server, you're on the Dell website, and it's like, I want the whole enchilada for the IPMI options. It's a $300 upgrade. Usually you can haggle with them and get a better deal than that. But on this system and like the other system, it's out of the box. You get it. It's full functionality, full screen share. You know, upload virtual media, the whole 9 yards.
So do you buy the chassis from Gigabyte standalone, or do you buy it with?
Usually you buy it from a reseller.
Okay.
So like the reseller will give you the warranty. So like an 8x5 warranty, or a 4-hour response time, or whatever sort of service plan you're looking for. So usually if you're going to buy like, what was that? Usually if you're going to buy like 10 or 15 servers at a time, then maybe. But usually your reseller would handle all that.
I see. For the, is there anything else before I ask specific? Oh, let's power splice. Let's talk about those. So these are very small. And
2200 watts.
And you've got 2 of them.
Light on. Yeah, it's designed to be redundant. So worst case scenario, they think this system could draw up to 2200 watts. So that's going to be 15,000 RPM drives with the fans running at the full 7 amps, with the CPUs pegged, with the full 4 terabytes of memory, with the crazy OCP cards pegged, and 3 V100s.
Are they, is it 7 amps, 12 volts for those?
Yep.
And you've got how many fans? 4?
4.
Is that really true? They can run at like 330 watts if you're
7
fully
amps.
pegged? Yeah.
Yeah.
7 amps, 12 volts times 4, so 336.
Yeah.
That's a hell of a lot of power for fans.
But 4,000 linear feet per minute, and
yes, right. For sitting in front of the nozzle of, I guess, 2 of them merging.
Yeah.
Yeah, that's impressive flow.
A lot of modern data centers are not, like in the olden days, the data center would be like 68 degrees, and that level of refrigeration was a real challenge. But modern data centers are made to run warmer, but as a result of that, you're going to have higher RPM fans.
Right.
And it's
yeah, but
louder.
you're not fighting with the AC as much, I guess.
Yeah.
Which is valuable. So they're redundant for each other, I guess.
Yep.
Like most enterprise products.
And hot swap, like the drives and the fans.
And these are just 40 mil fans on the back of these ones.
Yep.
And I guess we don't know the speed of these, but also fast when it's running.
Very loud when it's running.
Do I just, does it just socket? Okay.
Yep. It'll just slide right in here.
Anything else?
It'll click when you keep going.
I'm gonna let you do it. Okay. I don't want to be responsible for anything.
What did you do?
Yeah. You told me to push it.
But no, it's really like the most standard thing in the internal is like this OCP2. So like you can get the 40 gig Ethernet OCP2 cards on eBay for like $40. But you know, 125 gig and 100 gig is the new standard, and this is the OCP3 is the new peripheral standard. So like Dell, HP, you know, Supermicro, Gigabyte, they're all going to have OCP3 and 2 slots. And these are really popular because no matter what your other configuration is, if you're doing the half height, half length cards, or if it's configured like ours is for the V100s, you're always going to have those OCP2 and 3 slots, and they don't really count against you using your slot. So if you've got a really high density, you know, Gigabyte has another server that's 4 2-socket nodes into U. So you have 2, 4, 6, 8 CPUs in a 2U chassis, and the only real expansion you have are those OCP type cards.
We should point out this too, if you didn't already. Power cables, we were talking about this the other day. So those Teslas, they take EPS, 12 volt cables, they're not PCIe.
Yeah, normally you would get those power cables, but I got these because I was trying to rock the 2080 Ti's because I'm a cheapskate.
Yeah, real cheap.
Well, $7,000 Tesla V100s or $1,600 2080 Ti.
Yeah. In contrast, the rest of the system. But yeah. Anything else we should point out here? Cooler, I guess I'm a little curious about. So is this a TR4, like the same mounting holes?
Yep.
Okay.
And this heatsink is totally standardized. So it's a copper plate. And this is exactly the same cooler that you would find in a 1U server.
Okay.
But the reason it's 2U is so that you've got more room for your PCI Express cards.
So where does 1U cut off in height?
Right at the top of the power supplies.
Okay. So you'd have shorter fans in that instance, I guess.
Yep.
Do those typically, do they double up then? Do you end up with 2 times as many 40 mil fans or something?
Usually, but not always.
Okay. And what about water cooling? I know I've seen Asetek does enterprise products. How common is water cooling? Is it typically closed loop?
Right now, it's not super common, but Asetek has a whole rack water cooling solution with a bunch of quick release hoses.
Okay.
So they've got a standard that they're trying to create, yeah, because it's not, nobody really does it. But the idea is that for those super dense machines, you can do water cooling. And truth be told, I think that's really for like Intel, because their 56 core CPU is like 500 watts. And so if you want the density of 4 nodes in a 2U cluster, water cooling is your only option. These CPUs are relatively power sippy. I mean, you don't really need water cooling even if you're packing 8 of these in 2Us.
How does the water cooling normally work? So if you've got, let's say, a rack with whatever a normal amount of these might be, let's say 10 or something, do they stack them all and then run water cooling like externally out the back or something and route it to some radiator somewhere else? Or
yeah, usually the rack is a little wider than a normal rack, and there's a distribution port on the side.
I see.
And then in the bottom of the rack
they all hook into the distribution?
Yeah, and it's just rubber hoses, so like it's like a quick release thing. So like if you've ever messed with one of those and they sort of pee a little bit, it's like that. And so you pop it on and off. But theoretically, because it's like back here on the server, it does that far enough away from the server that you're not going to really have a fluid problem. And I think it's a non-conductive fluid anyway.
Probably, yeah.
So.
And then does that, you said at the bottom, is that where
that's where the tank and the refrigeration and all that is. I saw 2 configurations. One was at Computex, and it routed the hoses like it was designed for a data center that has a raised floor, and so it would route all the heat through the floor and like deal with it some other way.
Okay.
And the other one actually had the refrigeration unit in the bottom.
You're saying refrigeration unit, do they use radiator and fan at all, or do they just use some?
I think they use a chiller and a heat pump, and like there's a heat pump somewhere outside.
Yeah, that makes sense. Out of the building or in a different closet or something.
Yeah.
Cool. So water cooling not super common, but also necessary for the really high thermal density scenarios.
Not so much on the AMD side, but definitely on the Intel side with like the 56 core CPU or insanely high density. Some of the networking gear, like the 100 gig networking gear, not all of that is on the really advanced lithographies, so it produces a lot of heat. But there's not very many data centers that are that. It's what's the premium for floor space? So like at the New York Stock Exchange, it's really super premium. Yeah. So you're going to probably see that.
A lot per square foot, yeah.
But most of the other data centers, square footage in the data center is not really super at a premium. So those kind of technologies are not really necessary.
As I understand it, a lot of the time those are built in cheaper areas anyway, if they can.
Yeah.
And if they have the network infrastructure.
Yeah.
So I know last thing I can immediately think of, but other than an open-ended question for you at the end, but I know that Roman did a video overclocking EPYC at some point. Does any of that work on Rome?
It doesn't work the same way, but it is possible to overclock. So
have you done it?
A bit.
Okay.
I have not pushed the clocks past, so the upper clock on pretty much all EPYC CPUs currently is 3.35 gigahertz. And it is possible to get that 3.35 gigahertz clock on all of your CPUs, but with this motherboard, it's really designed, it seems like it's designed with a little bit of padding, and so you really don't want to push the CPUs more than like 280 watts before you start, like, things start getting sketchy.
Okay.
So
is this an instance where LN2 obviously brings your temperature floor down for the CPU and what's immediately adjacent to it, but is that a scenario where exotic cooling doesn't really help. You still have other barriers to overcome.
Yeah, you would still have the power delivery problem.
Okay.
And then that enters into like a PCB design and
Yeah, so basically you need like Gigabyte or someone to make a special solution just for that.
Yeah, there's a funny video circulating on the internet of some HP engineers. Like Intel did a demo of their 56-core CPU that was slightly faster than Intel's demo or than AMD's demo of this system. And then the HP engineers just published a video. It was unofficial, and it was not supposed to go on the internet, but they were looking at it and laughing, and so they just configured the CPUs for like 25 more watts each, and it leapfrogged the Intel CPU by like 1%. And so I was like, well, if you want to play that game, Intel, it's like
we can both do it.
Yeah.
Yeah, right.
And it was still less wattage.
Yeah.
So
cool. All right, open-ended question for you then. Is there anything else here that you think is really interesting that you want to point out, or any other projects you're working on with this that you want to bring attention to?
Benchmarking this is really hard. So if you want to see the benchmark, you can look for the level 1 video on this. I love bleeding edge hardware, and it really is like, this is sort of the pinnacle of human civilization in terms of computer engineering.
All right, sure.
128 core, and it's commodity. Like, this is a commodity part. We taught SAND to do billions of operations per second across 128 cores. What's not to love about that? It's so crazy.
Yeah, yeah.
But PCI Express 4 routing, I mean, it's so fast, and some of the other stuff. Like, look at the ridiculousness that they had to deal with for PCI Express 4. Like, all of the spacing and everything has to be...
we were talking about that, about the grounds.
Yeah, it's like they had to double up the ground pins here on the edges of the card connector. So PCI Express 4 is a huge pain, and you guys are going to have to deal with that on like I want to run my GPU vertically. Now you have another reason to recommend not doing that.
Yes, right. If we needed more, we have another one now. Yeah.
So
I think there's two interposers that claim they can do it right now. I haven't validated that, but
but it's so sketchy.
Yeah, I question it.
I like that even if you're running a GPU, a 2-slot GPU, you still got another slot available. Like
yes.
So it's like
some
3,
buffer.
6, 7, 8 slots. That's more slots than you get in a desktop.
Yeah, that's a Super Tower desktop. Yeah. Very cool. So if you want to see more of this stuff, first of all, we'll have additional videos on this channel with Wendell, including the one where we built our own
light version of this.
Light version of this.
Also with AMD technology.
Yes, it's got an R5 3600.
That's really good.
Is good. I mean, it's technically server technology in a lot of ways, but
people are going to laugh at that. But then it's like, if you buy an over $1,000 NAS off of Amazon, that's a 4-core Atom typically.
Oh yeah, yeah. And Atoms have had a lot of issues lately. Intel's had some issues with the Atom processors specifically. So that's a great point too. The DIY approach, you end up with a solution that's not complete out of box, but is cheaper for the power you get. So anyway, we'll have that video on the channel, if not already. And Level 1 Techs, you can get a lot more of this. Definitely go subscribe. I'll link it below. And I guess you already have a video up benchmarking this, or will maybe?
Probably by the time it's live, I hope.
Okay.
It's been hard.
And if not, go subscribe and you'll catch it as soon as it goes up.
Yep.
So you can get more there. And yeah, check back for the rest. Thanks for watching. You can go to store.gamersnexus.net to support us directly, like by buying one of the mod mats that we can now save this mod mat forever because it has touched a 128 core system. We will auction it off or something. And you can go to patreon.com/gamersnexus for behind the scenes. We'll see you all next time.
Thank you, and thanks for having me.